more network interfaces. We can have a primary network interface, secondary network interface, and so on and so forth, right? So all of that is possible. So I'm going to cover these two topics today. Okay, first let's get started with AMI. I'm going to share my screen. Just give me a second. Okay. Okay, so let's share my screen and give you. Okay, so AMIs, right? So now, what is an AMI, right? AMI, what does AMI stands for? AMI stands for Amazon Machine Image. Machine image, yeah. So now that's basically an image with which you spin up your instance, correct? You spin up your EC2 instance. So now when you build your EC2 instance initially, when you provision your EC2 instance initially, I mean, you actually choose an AMI, and then in AMI, you choose what type of AMI you want, right? I mean, you have different AMIs. So now let's take, for example, right? I mean, let's go, I'll open my whiteboarding's PPT. Okay, so now you have a EC2 instance. Yeah, you have an EC2 instance. EC2 instance, okay, which has an Amazon Linux 2 is the operating system. Okay. Operating system is Amazon Linux 2, and which has probably a web server installed in it, right? An Apache web server installed in it. Okay, which is actually serving some content, some web content it is serving. Okay, so now you have deployed some code on this Apache web server, which is your application. Your application is running on top of it. Okay, like let's say, for example, a hello world. We are going to create that right now. Okay, let's just do that. A hello world application is running on top of it, right? So this forms your EC2 instance, right? So basically, this is your EC2 instance, and your EC2 instance has got all of this in it. Okay, all these three things in it, your EC2 instance have got. So now, for some reason, right? So you EC2 instance crashes, right? You will lose everything, right? You will lose your web server settings, configurations, and you will also lose your application, correct? And then you have to again rebuild it from scratch. So again, what you have to do when you have to rebuild it from scratch, you have to provision a new EC2 instance, and you have to install Apache web server on top of it, and you have to configure your Apache web server, and you have to install your hello world application once again on top of your EC2 instance. So which is a time consuming activity, correct? Instead, what you do is you just take an AMI of it. Okay. Okay. So you can actually take an AMI of it, which is just a copy of it. Okay. And I'll just color it differently. This is basically the AMI. So now when you create an AMI of it, so what happens is your AMI is just a image of it, right? A copy of it, and it's an image. It's an AMI. Okay. So let me just call it as an AMI here. AMI. You just say my Apache hello world AMI is the name that I'm giving to my AMI. Okay. So now this is the AMI that I've created. Okay. And what you do is you basically use this AMI every time. Like say, for example, when your primary EC2 instance goes down, Okay, when this instance crashes and you're not able to recover this back due to some reason, what you can do is you can use this AMI, provision an exact same EC2 instance. Okay, and this is your EC2 instance 1, right? Okay, and so you can exactly provision an exact same EC2 instance, and then you can bring this up online. Okay, and what you may also do is when you have, so your EC2 instance will have what, I mean, it will have EBS volumes associated, correct? So let's assume my EC2 instance has got 2 EBS volumes associated, right? One is root, okay, which is root volume. The other one is slash data volume, correct? So now I'll call it EBS. This is also EBS volume, right? So now, for example, when your EC2 instance crashes, it probably has some issue with your operating system, right? I mean, that's where your root volume also crashes along with that, correct? So now that's when you are basically building a new EC2 instance with the help of the AMI. And then what you're doing is you are detaching it from your primary EC2 instance. So originally this is attached to your this EC2 instance, right? Both these are attached to your EC2 instance, correct? Okay, both these are attached to EC2 instance. So anyways, this is gone. You can ignore this. But what you can do is this, you can just detach it from this EC2 instance and you can attach it to the second EC2 instance. And this will also have your root volume. This will have its own root volume, which is because the root volume is coming from the AMI itself. This has the root volume because the root volume is coming from your AMI. So when you create an AMI, it's actually taking the snapshot of your root volume, and it is actually keeping that in as part of your AMI. Okay, so this is your AMI, and this has your root volume. And when you provision an EC2 instance, this whole thing gets copied as it is as a new instance, right? How many of you know object-oriented programming? Yeah, in Java, object-oriented programming concepts. Right, you would have learned about encapsulation, polymorphism.
Yes,
Oh,
sir.
yes.
Yes, sir. Yes,
Yes,
sir.
sir.
We have done.
So now I hear so many yes. If I give clues, so many yes comes out. Okay, all right. So what is the I mean, what happens, you know, when you create an object, right? And when you copy that object into another variable, what happens? You're creating an object, okay? And there are two variables, okay? And you're assigning the value of one variable to the other variable. So what happens?
Access the values from the parent objects, from the parent class.
Yes, so, but it does not disturb the parent thing, right? I mean, it really copies the object from the parent to the you know, the new variable, correct?
Yes, sir.
Okay, so now what happens is the same thing happens here also, right? When you have an AMI, this white box, right, with the white EBS root, that is the AMI. You know, it is actually not running. It's not a running instance. It is just an image. It is stored somewhere, but it's not running. It does not have an IP address. You cannot ping to it. It does not run. It is not running. It's not using any compute resources or memory resources, right? But when you actually instantiate it and when you create an EC2 instance out of it, right? Actually, it's not an EC2 instance. It's an AMI. Yeah. When you create an EC2 instance out of it, that is a running instance, which has an network interface. It is part of the VPC. It's part of the subnet, right? And you can ping to it and things like that, right? So that's what happens here, right? So when you create an AMI, it is a image which is a dormant image. I mean, it's not running. But when you instantiate that AMI and when you provision an EC2 instance using that AMI, that's an actual EC2 instance, which is a virtual machine which is running. Okay. And as part of the AMI, you can have your root volumes or any other volumes you can also choose to capture as part of your AMI. So when the AMI comes up, these underlying root volumes or any other volumes also comes up. But typically what happens is only the root volume is taken as part of the AMI to optimize on the cost, because your root volume doesn't change much. Only your data volume keeps changing, because that is where you're storing data and things like that, right? So now let us do a small lab around this, right? I'll show you how to take an AMI. Before taking an AMI, I'll also show you how to um, install Apache web server and run an Apache web server. Okay, just give me a second. I'm going to stop my screen share and come back with my console. Okay, so I'm here with my console. I'll share my screen back. Okay, so okay, I'm just going to go to Mumbai. I'll select Mumbai. I'm going to go to EC2. Okay, so I have two instances, but I have stopped both the instances. Let me just start only the public instance for now. Okay, I've started my public instance. Okay, so now what I'm also going to do is I'm also going to bring up my putty. Yeah, just bringing up my putty. Okay, so I have my putty here. But in the meantime, let me just check if my EC2 instance got fired up or not. Yeah, I think it is fired up. Okay, so I'm going to copy the IP address. I'll go to my putty. Yeah, I'm just going to go to my putty. I'll say ec2-user@. paste this SSH auth browse RPL Mumbai lab session appearance. Just going to make it open. Yeah, so it's connected. So I'm in my EC2 instance right now. This is my EC2 instance which is running. So first thing that I'm going to do is, I mean, this is a public EC2 instance, right? So I can basically I have internet access on this. So first what I'm going to do is I'm going to install the updates on this EC2 instance. So sudo yum update. So let's give that so that any updates that are there. Yeah, this has got some about 39 packages will need to be updated and one package will need to be installed. It gives a summary like this, and it's going to download about 79 MB of data. I'll just say yes. Okay, so it's going to update the EC2 instance. Let's just give it a minute or two while the EC2 instance gets updated, because it's always good to have the latest patches updated on in the EC2 instance, so that any vulnerabilities or any security loopholes in the older versions of softwares could be avoided. So it's always the best practice. So the command for that is sudo yum update. Okay, yum is basically a command to install something in a Linux, right? In a Red Hat version of Linux, right? So Red Hat, CentOS, Amazon Linux, right? You have to use yum, yum. Sudo is you are taking administrator privilege, and you're also you're elevating yourself to the administrator and installing it, right? Whereas in Ubuntu, it will be apt, sudo apt install apt. Okay, that's the difference between these Linux flavors. Okay, so I've installed it. So now what I'm going to do is I'll clear the screen. I'm going to install HTTPD. Okay, so now HTTPD is basically a web server, okay, an Apache web server. How many of you know what a web server means? Or how many of you have installed web servers and configured web servers to serve content, to serve HTTP content? Z011. Okay, who else? So which web server have you configured? Z011. Probably you have to unmute yourself.
I think he randomly raised hand before I.
He randomly. Okay, no problem. Okay. So okay, Z061 is unmuted. So which web server have you configured?
Apache Tomcat.
Tomcat you have configured. Okay, very good. Okay, so Apache web server. Okay, in fact, if you go httpd.apache.org, it's basically a open source. Apache is a open source community. Okay, Apache is a license basically. It's an open source. Anybody can use it. It's free of cost. And web server HTTPD. Okay, that is the name. That is the name when you install Apache web server on your Linux instance. It'll come as HTTPD. Okay, that's the name of the process that it'll come up. So I mean, you can read about it, and if you're interested, you can actually contribute to this. Okay, so if you go to the contributors, you'll see a lot of contributions there. In fact, I would strongly recommend all of you to actually contribute to some open source projects. Okay, that's where you really get a sense of building software that is used by millions of people, correct? And you'll exactly understand the scale of what's happening. If you see, these are the contributors of Apache. Okay, and okay, so anyways, this is the website, so you can just go through this. This is basically the web server. Okay, it's a very lightweight web server which is used very frequently, which is used by so many people. I'll say millions of people, millions of customers, millions of enterprises use this Apache web server, right? And they use the Apache web server. So let's get back to our EC2 instance. I'm just going back to my EC2 instance. I'm just going to say sudo yum install httpd. Okay, that is the command that you need to give. Okay, you're installing httpd, and it is sudo yum install httpd. So usually when you have to install softwares on your Linux instance, you use the phrase sudo yum install and give the name of the software. So httpd is the name of the software. Hit enter. It's actually going to process, and it said it's going to download and install one package, 1.8 MB. Yes, give the confirmation. Yeah, okay, it's installed now. Okay, so your web server is installed, and then so your web server will basically get installed in cd/where, okay, www. You see this folder, www, World Wide Web, www. It's called www. Okay, cd/where www, and this is where your Apache web server root home directory will be present. So now you can go to HTML and you can build your own HTML here. Okay, there's nothing right now here. So what you can do is you can just go build your own HTML. But before that, you have to basically check what is the status of the service. Sudo service httpd status. Okay, if you see, this is the status. It's inactive. It's dead because you have not started. You only installed the service. So when you installed, what Linux does is, what the yum does is, it basically creates a service called httpd within your Linux server, which will be listening on port 80. Okay, anyways, you can change all of that. I mean, my intent is not to kind of take you through web server concepts. My intent is to kind of take you through simple HTML. You're serving an HTML page through your web server called hello world. Okay, and then you're taking an AMI out of it. Okay, so now this is running. This is stopped currently. So now you have to basically go ahead and start it. So you can say sudo service httpd start. Okay, you start it. Yeah, so now it is actually started. So let's again see status. Yeah, status active and it's running. Okay, so now what you can do is, when you start this, you also get a default index page that when you start the web server, which comes by default. Okay, so now let's go back. Let's take the public IP address of my EC2 instance, because it's available publicly, right? My EC2 instance is available publicly, so I'll be able to access my Apache web server also publicly. I'll just say http://13.126.236.73. It's not going to work. It's going to keep saying that it's connecting to it. It'll time out. Can somebody tell me why it will time out? It's a very simple answer.
Security groups.
Excellent. Who's this?
A58.
A58. Very good. Awesome. So you don't have the right security groups in the web server. You don't have the right security group attached to it. Okay. So now let's bring the right security group. Let's put the right security group. If you see here, it doesn't have the right security group. Okay, so A58, can you tell me which port and protocol needs to be whitelisted?
80.
Port 80. Excellent. Okay, so you need to whitelist port 80 as part of your web server. Just a second. Give me a second. Okay, so what I'm going to do is I'm going to open the security group. Okay, and I'm going to allow inbound add rule HTTP on port 80, right? And then I'm going to allow it for 000. Anybody can access it, right? Because it's a public website. Okay, I'm going to put it publicly, right? So I'm just go ahead and hit on save rules. Yeah, it is saved. So now I'll just go ahead and refresh this. See, you get immediately you got it. Immediately you got a test page. This page is used to test the proper operation of Apache HTTP server after it has been installed. If you read this page, it means that your HTTP server installed at this site is working properly. You should get this test page, which means that I'm actually hitting my IP address, right? You can also do one thing. You can also hit your public DNS. This is also possible. Now, when will you get this public DNS? When you enable in the VPC, you have a DNS option, right? When you enable the DNS option, you will get this public DNS also associated with your EC2 instance. You don't have to use the IP address. You can also use the public DNS. I'll use the public DNS and hit it. I'm saying http:// paste the public DNS, which has EC2-13.126. Blah 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 dot ap south1.compute.amazon.aws.com. Just hit this enter. Yeah, here also you'll get it. Okay, so now let me go back to my EC2 instance, and I am right now in the cd/var cd/var page. Okay, this is the current working directory that I am on. So I'm just going to create a sudo vi index.html. Okay, so now when you want your own web page, right, you have to always use index.html, because that's how always the root will have point to index.html. So just say sudo vi index.html, and then I'm just going to give an HTML. So I'm sure a lot of you know HTML, right? So yeah, HTML h1 is header 1. I'll say hello RPL champs /h1/HTML. Excuse me. Yeah, so I'm just going to hit save WQ exclamatory. Yeah, so it is created. ls-l. Yeah, index.html is created. Cat index.html. Yeah, it has the changes, right? So now I'll go back and then I'll refresh this. Yeah, so immediately it will start serving from that index.html. It gives you hello RPL champs. Okay, so now you can also try this. You can also try hitting this particular IP address from your own machines. It's publicly available. Anybody can access this hello RPL champs from any of your public internet machines, right? 13.126.236.73. You can just hit this. You should get hello RPL champs. 13.126.236.73. Okay, so now let's do something interesting. Let's go back to our EC2 console. Okay, and here my website, let's assume I've built my website. Website is up and running, and all the pages are serving correctly. Let's assume it's a static website. It's a static website which is hosting your company's company's website, your marketing website, right? So it's your company's website, mycompany.com. Okay, and you want to take a backup of this whole thing, so that for some reason, if your website crashes, you will actually have a backup of your complete environment available. You can quickly build a new EC2 instance and you can bring it up. Okay, so now what I need to do is I have to select the EC2 instance, and then I'll say actions. Okay, and I'll go to instance settings. Sorry, images and templates. Actions, images and templates. And you have to use image, create image. Okay, just say create image. So images AMI. You will actually end up creating an AMI for it, and give a name to it. What is the name that we have used here? Yeah, my Apache Hello World AMI. Yeah, so that's the name. My Apache web servers AMI. Just give that, and you have to use this option no reboot, right? When you say no reboot, when you take an AMI, usually it reboots. Okay, then when it reboots, then you're actually causing a downtime to your website, correct? Or causing a downtime to your application. So you don't want any downtime to your application. So select this option, enable no reboot. Okay, so now something that interesting that you will see here, right? Instance volumes. Now let's go back to my EC2 console, and then let's see how many volumes my EC2 instance has got. Okay, I've got only one volume attached to my EC2 instance, right? It is actually listing that volume here. Okay, and then it is saying this is one volume which is attached to your EC2 instance, because if you remember yesterday, we cleaned up everything. I deleted all the additional volumes that I had provisioned. I cleaned up everything. So you won't see the other volumes here. Okay, and you'll also have an option here, delete on termination, right? So basically what happens is when you have a root volume is nothing but the volume which has the operating system installed in it, right? From which it boots, the EC2 instance boots from that root volume, correct? It's like you have your hard disk, correct? Your hard disk will have a boot partition. So your operating system, when you turn on the computer, it boots from that boot partition, correct? So similarly here also, the boot partition or the boot volume is this particular volume. So now usually you have an option to preserve it. Delete on termination can be enabled or disabled. See, when you enable it, what happens is when you terminate your EC2 instance, your EC2 volume also gets terminated automatically. But when you disable it, irrespective of whether you terminate or not terminate, your EC2 volume remains, EBS volume remains, right? Even when you terminate your EC2 instance, your root EBS volume does not get terminated. Okay, so now usually it's a best practice to enable this so that when you terminate EC2 instances, you don't have to specifically go to volumes and delete that volume. It's a double work. Okay, unless for certain specific reasons you would like to retain that volume, you can retain it, but you have to pay for that additional cost. That is the only caveat out there. Okay, so now let's go ahead, let's create the image. So here I want to keep it delete on termination, because when users create EC2 instance out of this AMI, and when they terminate it, this volume also gets terminated along with that. So I'll just say create image. Okay, so now image is being created. Now I'll go to images out here, and I'll go to AMIs. Okay, and here you have to select owned by me. You see a option here near the search bar. There's an option here, right, which says owned by me, public images. So these are all your public images, right? So when you actually provisioned your EC2 instance, you would have used one of these public images. Okay, and private images. So now private images are the ones which are present for this account. But you want to specifically see when you created an AMI, it will be owned by me. It will be under owned by me. You can either go to owned by me or private images. If you have admin privileges, you can go to private images. Or if you don't have admin privileges, you can just go to owned by me. You will see that this is currently being imaged. Okay, this will take a few minutes, where it's actually going to get imaged. Okay, and what I can do is I can just give a name to it. I'll give the same name out here. Okay, the AMI name is this one, and this is the ID of that AMI. Okay, and which source is this account. Okay, this is my account number. Owner is this account. Visibility is private. It's a private. I'm not sharing it with publicly, right? So it's private. Status when it is created. What is the platform? It's Linux platform. What is the root device? Root device is EBS. What is the virtualization? Ignore that. Okay, so it's available. It's created. If you see, your AMI is created. Okay, so now let's do one thing. Let's get a little adventurous. Okay, so I'm going back to my public EC2 instance. Okay, and I'm actually cleaning up certain things, but by mistake, I deleted my public EC2 instance. Okay, I terminated my public EC2 instance. If you see, my website is running, correct? My website is currently running. I'm able to hit the website. You can also try by hitting 13.126.236.73. You will also get hello RPL champs here. Okay, and so what I'm doing is I'm actually going and I was intending to clean up something, but by mistake, I deleted my corporate website, which is very, very important. I'm just going instance state and I say terminate instance. Okay, and I deleted my EC2 instance by mistake. If you see immediately your connectivity to the putty will go for a toss. Connectivity is gone to putty. I'll just close putty because I won't be able to use this putty instance any longer because connectivity is gone. Okay, so now my end users are actually trying to access the website. I'll just refresh this. You also can refresh it and tell me whether you're able to hit the website or not. Is it coming up for any of you? Are still able to see hello world, hello RPL champs?
No, sir.
No, sir.
No,
No,
that's
sir.
because my EC2 instance is gone. Okay, my EC2 instance is gone and it's terminated. Okay, so now my boss comes to me and he yells at me, "Hey man, what have you done? You have deleted our company's corporate website." Okay, and he's reprimanding me very strongly. Okay, so now I tell my boss, don't worry, I have a backup. I can bring it back in the next 5 minutes. Okay, so now what I do, I launch a new instance. Okay, in the new instance, if I select this, then I have to do the setup from scratch, correct? If I use Amazon Linux to AMI, the usual way, I have to do all the setup manually. Instead, what I do is I go to my AMIs. Okay, I have my Apache Hello World AMI, which is available. I select that AMI. I use t2.micro, configure instance details. I put it in subnet 1A, okay, so that it's publicly available, and auto as an IP address is enabled so that it gets a public IP, and I can map it to my DNS so that people will be able to use it as usual. Okay, and I just say next, add storage. So here by default it has the root volume, correct, which has my website in it, and you see this delete on termination is there, so it's there. Next, add tags. I'm just going to add a tag, name, public EC2 instance. Next, configure security groups. I already have a security group. I don't have to recreate one. I have this. This is my security group, which has port 22 open to public and port 80 open to public. I'll say review and launch. Yeah, everything looks good. I just say launch. I acknowledge. I use my RPL Mumbai lab because that's the key which I had earlier used, which is already there. And I'll say launch. And go to view instances. Yeah. So now this is in a pending state. Let's just give it a few seconds. It will come to running state and we'll be able to connect to that, log into that. Just give it a 30. Okay, perfect. It's up and running. You see, less than 20 seconds, my EC2 instance came up and my status checks are also running. Okay, so now let me go to the details. I copy my public IPv4 because if you see, the public IPv4 has changed. Okay, and even my private IP address has changed. If you want, you can retain your private IP address. I'll tell you how. But my public IP address has changed. I'll go back to putty. I'll open my putty. I will say ec2-user @ public IP address. I'll go to SSH. I'll go to auth. I'll use my RPL mobile app as the key. I'm just going to change this. Okay. I'll just say open. Yeah, so I connected to my EC2 instance. So now, what would you think? Sudo service HTTPD status. Okay, it is actually stopped, but you can start it. And just start it. Yeah, it is started. So now let's go back to the browser and give the new IP address here, the browser, which is this. Yeah, you got it. You got it back. I didn't do anything. I just started my HTTPD and my code, whatever the HTML code that I had, just came back. You can try this 15.206.116.214. And let me know if you're all able to access it, or a few of you.
Yeah, we are able to access.
Yeah, you're able to access it, right? So now, yeah, my corporate website is back up and running. As I promised to my boss, in less than 5 minutes, my corporate website is back in action, right? So that's the power of AMIs. So now if you see, I just created an AMI. I use the AMI to bring back my system back, okay? And I mean, this can happen anytime, right? I mean, when in this case, I purposefully terminated it just to show you, but it can happen inadvertently when operations engineers or cloud engineers are actually trying to work with the systems. You know, mistakes do happen, right? I mean, there could be loopholes in the process. There could be human errors. Human errors are always possible, right? So that's when, if you see, you actually have an ability to bring back your backup into action and then get it up and running in less than 5 minutes. Okay, and if you go back to your EC2 instance, you can go to cd/var www HTML. You will see that index.html is there. Okay, so now what you can also do is usually you take AMIs and you need to choose the root volume as part of the AMI. Now let's assume I also have another data volume associated with my EC2 instance. I provision like yesterday's lab example, right? Where we provisioned a new EBS volume and attached it to the EC2 instance, and we also mounted it on the EC2 instance, and the application was actually writing some data to that volume, correct? So in that case, it's better to go for snapshots. You keep taking snapshots of that EBS volume, of the second data EBS volume, so that it keeps taking backups every 3 hours, every 4 hours. It keeps taking backups. After that, what happens is it actually when a mishap occurs and when you lose your EC2 instance, you can bring your EC2 instance back from AMI, and all your data volumes you can bring it out of the snapshots. Okay, all your data volumes are being snapshotted, so you can bring your data volumes out through the snapshot. And what you can do is you can actually create a lifecycle policy, okay, where you can say that keep your snapshots. You can create a lifecycle policy where you say that, okay, I'll show you how to do that. For that, what I'm going to do is I'm first going to go create a volume. Okay, right now I only have 2 volumes, right? One belongs to my private EC2, other one belongs to public EC2. It's a root volume. I'm going to create a data volume of 30 GB, AP South 1A. I'll not choose any snapshot. I'll just say add, name is data volume, create volume. Yeah, let's wait for the volume to get created. Okay, it's available. So I'm going to select the data volume, actions, attach volume, attach it to my public EC2 instance, which is running, /dev/sdf, attach. Yeah, it's actually attached. I'll go back to my EC2 instance. I'll follow yesterday's examples, yesterday's steps. Okay, what are those yesterday steps? If you open your document, you will know. Yeah, just follow these steps. Okay, and once you have that, once you get to this page, go to execute 9 to 15. Okay, lsblk. You have the 30 GB associated here. So now I'll just say sudo mkdir/data. I've created. Okay, /data already exists. Okay. Okay, /data already exists. Yeah, because I created it yesterday. Okay, yeah, it's the same, right? I created it yesterday. So I'm just going to say sudo mount. Okay, before that I need to format it, right? I'll just go ahead and format it because it's a fresh volume that I created. So I'll format it. Yeah, it's formatted. So then I'll just go to sudo mount. Yeah, it's mounted. cd/data. ls-l. Yeah, there's nothing, no data in it. I'm just going to sudo va file1.txt. Okay, yeah, I've created a file 1.txt. So now what I can do is I can just go and I can actually set up a I can take a snapshot of this, right? I showed you how to take a snapshot of this, right? But before that, what I can do is I can actually create a lifecycle manager, right? Which is automated. So I can just go to lifecycle manager where you can schedule and manage the creation and deletion of EBS snapshots. I'll just go hit on create a lifecycle policy. So now what is a lifecycle policy? A lifecycle policy is something which manages the lifecycle of a certain resource. In this case, it's managing the lifecycle of your snapshots, EBS snapshots. I'm just going to give my data volume snapshot policy is the name that I'm giving to that. And I'm going to select volume here, or I can even select an instance. Okay, any instance or any volume with the tag, with the specific tag. Imagine this is where your tags are going to be very, very useful, right? Where you have a tag for your EC2 instance. What is your tag? Public EC2 instance. I can also add additional tag to this. I can say purpose. I'm just going to say web server. That's a tag that I'm giving. So I'll just save it. Okay, so now if you see, this has got 2 tags associated with it. Yeah, purpose is web server, name is public EC2 instance, right? So now the way lifecycle policies work is when you create a lifecycle policy with a specific tag, it always looks for the tags in any of the resources, and then it applies the lifecycle policy on all those resources, right? It's like that. So it's like, you know, a general universal thing, right? So where you want to automate certain things, you use tags, and then you use that tag value to automate in your lifecycle policies or in your Lambda functions or in your cloud formation and things like that. Okay, so what I'm going to do is I'm going to basically say purpose. I'll just refresh this. I'll say create lifecycle policy. My data volume policy, snapshot policy. Okay, I'll just go to instance. I will say purpose as web server. Okay, web server is the name that we have given, right? And if you want, you can give a name to this tag itself, to this policy itself. Just leave it. IAM role, ignore it for now. Yeah, just ignore it. And then here is where you can give a schedule, right? You can just give a schedule here. Now, my boss has asked me to back this up every 4 hours. Okay, I will say that 4-hour backup schedule is the name that I'm giving to my backup, and then frequency is daily. Run this daily. Okay, and then every 4 hours you can give this. Run this daily, no exceptions, and run this every 4 hours, starting at 9 UTC. What is the UTC time now? It's 4:29 AM, right? I'll just say 4:35, so that it starts immediately. 4:35. Yeah, 4:35 AM. I'm just giving 4:35 AM. Retention type, you can actually retain, like, for example, right? I mean, when you have backups running every day, you don't want to retain all the backups, right? You only want to keep the recent backups. All the old backups, you want to just recycle them. You want to delete them, so that when you create a snapshot, it's an additional cost, right? Storing the backup in your account, and that's an additional cost for you, right? So you might want to say that retain it by count or age, right? You can say that retain count is keep 15 copies or 15 backups, right? Every day, 4 hours it's taking, right? So which means 6 times in a day it takes. Every day, every 4 hours, every day. So 6 times in a day it takes backups, right? And so 6 plus 6 is 12, 12 plus 6 is 18. So what it does is after 3 days, it actually deletes it only keeps 15 backups, which means the last 2 days of backups it keeps, or last 2.5 days of backups is what it keeps. It can be either by count or it can be by age also. Okay, delete after 5 days. You can say delete after 5 days or delete after 2 days. You can do that. Okay, so now what I'm going to do is I'm just going to go by count. I'm going to say maybe retain only 4. Okay, I'm going to leave it like this and come back and show you tomorrow. Okay, so that it would have actually taken 6 backups today, right? From now till tomorrow, it would have taken 6 backups, correct? But I'm only retaining 4 backups, so it should delete 2 backups out of it. Okay, so that it should only retain the last 4 backups. I'm going to leave it like this. You don't have to do it. It will unnecessarily incur cost on you. I'm going to do it, and I'm going to come back and show you tomorrow. If I get diverted into other topic, you can ask me to show this. I'll show this to you tomorrow. Okay, and then this is additional optional tagging information. You can just leave all of this. You can ignore all of this. And this is also an important thing. So usually when snapshots are taken, it is a regional entity, right? Because I'm taking a snapshot in Mumbai region. So it is actually stored in Mumbai region only, within that availability zone. All the snapshots are stored within that availability zone. Okay. But yeah, a copy of that snapshot is also there in the other availability zone. So that's why you're able to restore it in the other availability zone. But it does not go across the region. It does not go to another region like Singapore or North Virginia or Ohio, right? Or Oregon or Sydney, right? So if you want your snapshots to be available in a cross region, then you have to enable this cross region copy. So whenever a snapshot is taken, it will automatically take that and copy it over to the other region, so that it is there in the other region, and you can actually use it in the other region also. Okay, I mean, if for example you want for a DR, disaster recovery, you want to copy all the snapshots to other region, so that when there is a problem with one region, you can easily bring up all the backup in the other region, and you can get back your services up and running. Okay, I'm not going to do that. I'm just going to leave it, and then say enable policy. I'll say create policy. Okay, so what is the time now? Sorry, did we cross? Okay, in another 2 minutes, if you see, this should kick off. Okay, right now it's 4:33. Okay, the policy is created now. It's enabled. Okay, and the schedule is so right now, if you see, okay, so right now, if you see, okay, this is part of your AMI. Okay, your AMI also takes a snapshot. So you just ignore this. This is part of your AMI. When we created an AMI, this snapshot is taken from created by AMI on the root volume. So ignore this. But now once we hit 435, yeah, in another few seconds, this snapshot should kick in, and you should be able to see that it will start creating a snapshot here. Let me just keep refreshing it. Yeah, in another few seconds, it should actually come up. Once it hits 435, yeah, 435. Now let's go back to snapshots and refresh. Actually, the policy will get triggered at 435. It's actually going to take a snapshot. Okay, so now the trigger would have triggered. Yeah, let's just give it a few minutes. It's actually taking the snapshots. So let's just give it some time. It's going to come and create a snapshot of that of the DC2 instance. Let's come back after a while, and then we can see that it would have actually created a snapshot of it, because we have a tag called purposes. Yeah, purposes web server is the tag that we have, correct? So yeah, it'll come back and it'll just take a snapshot of it. Okay, let's come back to this in a while. Just give it some time. Let it finish. Okay, so now we looked at how to take snapshots, how to configure policies, and also how do you take an AMI, most importantly, right? How do you take an AMI, and how AMIs can be useful, right? How AMIs can be useful, and how you can actually bring back your system intact using AMIs. Okay, and we looked at AMIs, we looked at snapshots, we looked at manual snapshots, we looked at automated snapshots. Now let's go to network and security. Okay, security groups, all of us know what security groups are. Security groups are instance firewalls, which protects your firewall, which protects your instance, and it allows only certain traffic to flow to your instance, such as specific ports on protocols and from specific sources. The moment you give 0000, it means it is all sources. Okay, here 000000 means all sources, but it's only allowing on TCP port 80 and TCP port 22, right? It's not a best practice to allow inbound rules with all protocols, all ports, all sources. That's not a best practice. Okay, which means that you're having a security guard, but you're telling your security guard to allow every Tom, Dick, and Harry inside. Okay, so now let's come to network interfaces, right? Network interfaces are again interesting. So now, okay, so now what happens when you create an EC2 instance? Okay, what happens when you create an EC2 instance? You go to networking, you get a public IPv4 address, and you get a private IPv4 address, correct? As I said last time, some time back, your public is publicly facing, private is private, and your NAT happens Okay, with respect to your public IP address, correct? Your public IP address is externally facing, and your private IP address is internally facing. It's like your telephone, office telephone example that I gave. Okay, so now this private IPv4 address is coming from your subnet range, correct? What is your subnet range? And you just open the subnet range. I'm just going to close all of this. Yeah, so what's your subnet range? Your subnet range is CIDR ranges 10.0.10/24, right? So your IP address is actually coming from 10.0.10/24 range, which is 10.0.1.243. Okay, so that's how it basically goes. And it gets one of the available IP addresses from the subnet side array, and it allocates it to this private EC2 instance, to the private interface of the EC2 instance. So now if I go to the network interfaces, okay, there's something called elastic network interface. Okay, it's called ENI. Okay, the elastic network interface is basically when you provision a new EC2 instance, and when when the EC2 instance gets as part of your subnet, it needs an interface, right? It needs a network interface, like how you have a network interface in your laptop or a desktop, where you plug your RJ45 cable or you connect to Wi-Fi, correct? It's a physical interface, correct? So similarly here also it's an interface, but it's a virtual interface. It's not a physical interface. The physical interface is part of your underlying host, which is the server, which is the physical server which is hosted on the rack. So now if you see, this is the network interface which is attached to my EC2 instance, which is there in the public, which is there in my South 1A, which is my public subnet. Okay, and what it has is this is a primary network interface, and it is attached to this particular EC2 instance, which 91E53. What is 91E53? I'll go to my EC2 instance. Yeah, so 91E53 is my public EC2 instance. Okay, it's actually attached to that public EC2 instance, and if you see, it has two interfaces, right? So one is the public and private, right? Now my public EC2 instance has got a public IP associated with it, whereas my private doesn't have a private IP because it does not have. It is not a public subnet. It's not in the public subnet. This guy is in the public subnet, so he's getting a public IPv4 address associated with it, and it also has a private IP address, right? 10.0.1.243, and this is 10.0.2.8. That's the private IP address. So it has the IP address associated with that network interface. Okay, actually, if you see, the private or public IP is associated with that network interface, not with your EC2 instance. I mean, through the virtue of network interface, it is attached to your EC2 instance.
Next slide, I given as a 20% I'll use.
Yeah. Okay, so so if you see here, that's how it is. That's how it is connected here. And you can see that you can see more details about it. Okay, you can also see that the security group is actually associated with the network interface. Very important. You have to understand that when I say security group associated with my EC2 instance, it's actually associated with that network interface, because that network interface is the entry, right? Entry point for all the traffic that is coming inside, right? So it's actually being blocked at the network interface level itself. It doesn't even reach the EC2 instance, right? I mean, you can imagine when you create a security group, you may be thinking that Amazon AWS is doing something within the EC2 instance, where AWS is going inside the EC2 instance and it is enabling firewall within the EC2 instance. No, that is not the case. It is not even going inside the EC2 instance. At the perimeter itself, where there is a network interface, it basically blocks the traffic at the network interface level itself. That's why if you see, the security group is associated with the ENI. It's called ENI, Elastic Network Interface. Okay, let me just go here and I'll just pull up some network interface. Okay, An elastic network interface is a logical networking component in a VPC that represents a virtual network card, right? You have a physical network card, right? Similarly, this is a virtual network card. It can include the following attributes: a primary IPv4 private address, one or more secondary private IPv4 address, one elastic IP address per private IPv4. I'll tell you what an elastic IP address means. One public IPv4 address. That's what we had, right? So we had one public IPv4 address here, correct? Yeah, this is one public IPv4 address that we have. One or more IPv6, one or more security groups, a MAC address. It has a MAC address also, right? What is a MAC address? Can somebody tell me? Have you all come across MAC address? MAC. It's a very important
Media
concept.
access control.
No.
Media
It's
access
same
control.
error. I think the accuracy is 97.
Communication
media
with the network.
Physical address of the device.
It's a physical address of the device. That's correct. Which device?
Starting from 5
Physical address of the network.
Hello?
Physical address of the network.
Not network. You're partially right, but it's not the network.
Physical address of network adapter.
Exactly. The physical address of the network adapter. Okay. So now I'll just go to one of my Windows machines. I'll just say CMD, open the command prompt. I'll say ipconfig/all. So I have a Ethernet adapter, right? If you see, this is a physical address of the Ethernet adapter. So now if you see this physical address, right, which is basically about 12 characters long, correct? It's 12 characters long, correct? So now this physical address would be unique across the world. Okay, and every manufacturer, right? I mean, every network card manufacturer ensures that this physical address is kept unique across the devices that they manufacture. Okay, so now if it is like 12, then the permutation combination, you can imagine how many permutations combination is possible to create those many number of network interfaces in the world. Okay, so but in case of virtualization, again, you know, for virtualized network interface cards,
explain करता है यार, लेकिन unfortunately
A29, can you please go on mute? Okay, so if you see, this is basically the physical network and physical address of your network interface. Now that's where, if you see, if I go back to my, it has a MAC address and a source or destination check flag. There's also a source or destination check flag which says whether it is true or false, right? So now in this case, as I said, when we created NAT interfaces and you had enabled the source or destination checks, correct? Yeah. And then it has a description in it. Okay, so you can just read through this. It'll give you some basics about what the primary network interface is all about and what public IPv4 addresses for network interfaces mean. But what you can do is, more importantly, you can create a new network interface, and you can say that secondary interface. Okay, and you can put it in subnet 1A, which is my public subnet. Okay, and I can auto assign a private IPv4. So always ENI is private. Okay, remember that. Elastic network interface is always private in nature. It's not public in nature. If you need a public IP address, you need to go for elastic IP address. I'm going to address that next. and you can either auto assign or you can give a custom, right? If you have to go for a custom, then what you do is, so now this is 10.0.1.2.4.3, right? I'll make it 2.4.4. 10.0.1.2.4.4. Okay, and then I'll assign this security group to this particular 2.4.4, and I'll add a name to it. I'll just give the same secondary interface, and then just say create. Okay, so it's created, and it's 10.0.1.2.4.4, and it's actually available. It's again similar to volume. It's again available. So what you have to do is you have to go and attach it to an instance. So now in that subnet, whatever instance that is running, it will list down everything. I'll attach it to my public EC2 instance. I'll just say attach. Okay, so now you have it attached to your public EC2 instance. So let me go back to my EC2 instance. I'll just hit refresh. I'll select my public EC2 instance. I'll just go to networking. Yeah, you see this? It has 2 private IP addresses because it has 2 network cards. Okay, so usually what happens is when you are deploying applications in your data center, even you take a physical server, right? A physical server will have 2 network cards. It will not just have a single network card, because having single is always a single point of failure. Okay, in architecture, right? You take any architecture, you should always go for, you know, redundancy. That's called redundancy, right? It's called redundancy and high availability, right? I mean, you take flights also, right? So when flights are designed, flights have twin engines, right? If one engine fails, that is the other engine is there to protect the flight, right? And flight can actually run on one single engine, right? So that way, if you know, if the switch where the network adapter is connected to, if that switch fails, you at least have the second network adapter through which the traffic can flow in and out. Okay, so if you see, it has got 2 network interfaces attached to it, and you will get those 2 visible on your screen, and you can use either of these to interact with your EC2 instance. Okay, but of course this is a private one, but you can use either of this, right? In fact, I can just do that quickly. I'll first connect to PuTTY, and I'll first connect to the private EC2 instance, and from private I'll try to ping to this. Okay, yeah, so I'll just go to my home directory. Yeah, okay, so this is search -i. Okay, I'll start my private EC2 instance now. It's stopped. I'll just start it. Just wait for this to be started. Okay, I think I can still connect to it. EC2 user address 10.0.2.8. Yeah, it's connected to my 10.0.2.8. Now I can actually try pinging my my public EC2 instance from my private. Okay, so what is my public EC2 instance IP address? First IP address is 243, right? So that's what we are given originally, correct? 10.0.1.2.4.3. Ping 10.0.1.2.4.3. Okay, I'm not allowing ping traffic. Let me look at the security group. Yeah. Okay, I'm not allowing the ping traffic from my range. I'll just add 10.0.0.0/16. I'll give the entire VPC range to allow the ping traffic. Let's just say save rules. Yeah, immediately it started pinging. Okay, I'm able to ping my 243, which is my primary network interface, right? That's my primary network interface, which is 243. But I added secondary network interface also, which is 244. Let me try pinging 244. Yeah, it can still ping 244 also with the same. Okay, if you see the latency is like 0.7 milliseconds, pretty much you get the same here also. Okay, so now you can use either of these interfaces 243 or 244 to connect to the DC2 instance. So that way, you're actually creating a redundancy, and you're basically having some sort of redundancy built into your application that you have deployed on the EC2 instance. Okay, even if one network interface fails, you have the second network interface. That is one way of looking at it. And also, when you have when you're building some say network devices like firewalls and all, it should have multiple network interfaces, so that you can actually scan, you can restrict the security groups, and you can make one network interface as trust, the other one as untrust, and things like that. Okay, I'm just giving you some examples. You may not understand that completely, but just remember that you can associate multiple network interfaces to your EC2 instance, and you'll be able to connect to those network interfaces using either of the network interfaces. Okay, that's on network interface. Okay, so now elastic IPs. Now ENIs are private in nature, right? But what if I want a public IP associated with my EC2 instance? One way of doing that is you have a public subnet, and you provision a EC2 instance in the public subnet. By default, you will get an IP address associated with it, right? By default, you will get an IP address associated with that. So now that is the public IP address that I have here, right? So it's just 15.206.116.214. But what is the problem with this? When I restart my EC2 instance, this goes away. Correct? When I restart my EC2 instance, this public IP address goes away, and it allocates a new public IP address, right? So now, what if I want my public IP address to be static? I don't want ever changing public IP addresses whenever I restart my instance. I want my public IP address to be static in nature. So that's when you have to use elastic IP address, where you go allocate an elastic IP address, which basically what it does is elastic IP is always public IP address in nature. Okay, allocate an elastic IP address from a public IPv4 address pool, or use global IP addresses from AWS Global Accelerator. You can have one EIP associated with the instance, with the running instance at no charge. You are charged for additional EIPs that are associated with the instance. Elastic IPs that are associated with stopped instances or unattached network interfaces. Yeah, so basically you're charged for additional EIPs. If you associate exactly just one IP address to your EC2 instance, you're not charged. But if you associate one or more than one elastic IP addresses to your EC2 instance, you are charged. Also, if you have just allocated elastic IP addresses and you're not using it, then you're still charged. But for example, in this case, I just want my IP address, public IP address, to be static in nature. Okay. So now what I do is I go allocate an elastic IP address. I'll just say allocate. Yeah. So if you see here, yeah. So I have a new IP address allocated to my EC2 instance, which is this one, 3.7.238.6. Okay, but it's not associated to any instance right now. What I can do is I can just go ahead and associate this to an instance. Associate elastic IP addresses. Click on actions, click on associate elastic IP address. I can associate it to an instance, right? I'll just select an instance here. I want to select my public EC2 instance, and which private IP that I want this to be associated with. I will associate it with my 243 private IP. Right? So that's that way it can NAT. Again, it is doing a NATing, right? You can understand the concepts here, right? Where it is NATing your public IP address, which is 372.38.6 to your private IP 10.0.1.2.4.3. So you're creating a mapping through NATing, network address translation, right? And then say associate. Okay, in fact, there's already an IP associated with that, right? Because if you go back, if you go to your network interfaces and you look at 243, 243 also already has got a public IP associated with it, right? So what you can do is you can yeah, you can just send this as your okay. In fact, if I do is allow this to be associated. Specify an interface ID. What is the network interface here? It is 565D. Okay, so I allocated a new elastic IP address, which is this one 372.38.6. And what I did was I associated that with the network interface of this network interface, which was provisioned initially, correct? So this originally had 15.206. Now if I refresh, it would have changed. See, now it would have changed. It would have changed to 372.38.6. Okay, but what this star means is it's basically a public IP address. Okay, and if you go back here, 372.38.6 is a public IP, which is an elastic IP address, which doesn't change. It's permanently allocated to me, to my account. Okay, I can now associate it with any EC2 instance that I want. So when I associate my elastic IP address to an EC2 instance, even when the EC2 instance reboots, this IP address won't change. This will be the permanent IP address associated to my account, and I can associate it with any EC2 instance, right? So now you don't have to worry about, now originally, if you remember, when I brought up my HTTPD server and I gave hello RPL champs, you all used one of the old IP address to connect to that. It connected. So then when I rebooted, when I brought my server, when I terminated my server, and when I again recreated my server using the AMI, the IP address changed. So then again, you have to change the IP address at your end, correct? So now that's a major change, right? When end users have to keep changing the IP addresses that they're connecting to, then it becomes a problem. Of course, you can do it through DNS, but again, DNS propagation needs to happen, correct? So now instead, easy way is you allocate an elastic IP address, which this 372.38.6 is in your account permanently. It's allocated to you permanently. Now you can associate it with any EC2 instance. Whichever EC2 instance that you associated with, that EC2 instance will get this public IP address. Okay. So now let's go to EC2 management console, and I'm going to go to instances. I'm going to public EC2 instance here, and then let's check what is the IP address that it has. See, it has 372.38.6, correct? So now let me just go connect to my EC2 instance through that. This would have got disconnected. I'll close this putty. I'll open a new putty connection. I'll just say EC2 user at the rate. Just say open. Yeah, so it's able to connect to my EC2 instance, correct? It's able to connect to my EC2 instance, and I can actually, my web server is also running on that, right? So I'll just say Control V, http:// yeah, hello RPL champs is there. So now what I'm going to do is I'm going to restart my EC2 instance, right? If you don't have an elastic IP associated with the EC2 instance, you would expect that, you know, the IP address would change, right? But what I'm going to do is I'm just going to go reboot instance, stop instance. And private IPs won't change because I'm using the same network ENI, right? So private IP addresses would also remain the same. Okay, it stopped. So for the stopped, even though it is stopped, if you see, my public IP address still is associated with that. Usually, when you don't have a elastic IP associated with your EC2 instance, and when you stop it, this would immediately go away, correct? But in this case, it still is preserved. So now you can just start it. Yeah, if I go back to my putty connection would have terminated, but I don't have to do anything. I'll let the instance come up. I'll just refresh my putty. My putty should be able to connect to my EC2 instance. Yeah, so I think it's up and running. I can actually go back and I can say right click and restart session. Yeah, it connects the same IP address. It still connects. It has not changed the IP address, correct? So that's the idea of elastic IP addresses.
Yeah.
Yeah. Okay, so we looked at security groups, elastic IPs, network interfaces, key pairs. You know key pairs. You have already created key pairs earlier, right? And you know what key pairs are. Again, placement groups. Placement groups are nothing but, you know, when you can read more about placement groups in the documentation. But placement groups are a way to place your EC2 instances in such a way that, you know, there are multiple different strategies for placing your EC2 instances. Like when you want to ensure that, you know, you have your EC2 instances you know, spread across multiple different racks. You have a data center, right? And you have multiple different racks and multiple within an availability zone. You know, within a data center, you have multiple racks. So now you might want to isolate your EC2 instances from a rack failure, because a rack could fail. An entire rack could fail, right? Because probably a power connection that is going to the rack is damaged, and you know, the entire rack could fail. So now if you put all your EC2 instances in one rack, so then all your EC2 instances would go down, right? So that's where, if you see, placement groups are nothing but a strategy which would place the instance in such a way that all of your instances are spread out across underlying hardware to minimize correlated failures, right? Because usually what happens is when failures happen, they're correlated with each other. So you do not want to be a victim of such correlated failures. You can use placement groups to influence the placement of your group, of a group of interdependent instances, where you have cluster, partition, and spread. Cluster is it packs instances close together inside an availability zone. This strategy enables workloads to achieve the low latency network. So now in this case, you know, the latency would vary, right? When you place everything in one single rack, or you place everything in, say, one single availability zone, correct? So now typically if you take high performance computing applications, which has a very stringent latency requirements, you know, you could go with a cluster. So where you know, what AWS does is, the algorithm does is, it ensures that it places all the EC2 instances which are part of the cluster probably in a single rack or close to each other. So that way the latency is not too high. Similarly, you have partition and spread. Okay, you can just read about it later. It's quite interesting as to how AWS gives you the ability to choose a strategy while placing your EC2 instances. So that way you are isolating yourself from failures. Okay. In fact, I'm going to tell you a few more interesting things like Netflix. I'll talk about it sometime later, how Netflix has actually built their entire architecture on AWS. So when users play Netflix, that's how how they protect themselves from failures and ensure that end users are not interrupted due to failures, due to underlying failures. All right, so I think we're good with this. So what we are left with probably is load balancing and auto scaling, which will come back later. I'm going to make you build some applications using EC2 instances. When you build some applications using EC2 instances, you can use load balancers. Yeah, can everybody go on mute, please? Yeah, you can use load balancers and auto scaling groups. Auto scaling is where you auto scale based on, say, if CPU load is high, CPU load gets higher, it'll automatically add a new EC2 instance using the AMI, and then it'll spread the load between multiple EC2 instances. That is called auto scaling. So we'll do some of those labs a bit later, but right now, I just want to introduce you to concepts. Right, once you understand the concepts, and maybe subsequently we will do more lab sessions. I'll make you build some applications on EC2 and deploy those applications using load balancers and auto scaling groups and so on and so forth. Okay, so now I think let's kind of take a logical pause here. I'm going to give you the assignment for today. 3rd November is what all topics we covered. AMI, snapshot, lifecycle manager, elastic network interface, elastic IP addresses. Okay. Yeah, there's some machine images. Yeah. Elastic network interfaces. Elastic IP addresses. Yeah, so just read through these. I think you should be good. You don't have to do everything, right? I mean, some of these are chargeable, so you can just skip that. But anyways, you can replay the video for concepts. Anyways, those are things that you won't be doing on a daily basis, like allocating an elastic IP address is something that you won't be doing on a daily basis. But I wouldn't recommend you to allocate an elastic IP address in your account, which will unnecessarily charge your account. Okay, so first thing that you do is Amazon machine image, right? So boot up the public EC2 instance. Okay. Putty to the public EC2 instance and install updates using sudo yum update and then give confirm with yes. Okay, so once the update is done, then install Apache web server using sudo yum install httpd confirm with y. Okay, so once httpd is installed, then start the Apache web server service sudo service httpd start. You can also check the status by sudo service httpd status. Okay, once that's done, go to your browser and access http:// your public IP address. Should be able to. You should be able to see the Apache test page. Okay. Once that's done, then what you can do is you can just go back to putty and putty, go to /var www/html. Okay, create a new file using sudo vi index.html and give html h1 hello world /h1/html. Okay, once that's done, save the file, right? And then again go to your browser. Should be able to see the hello world page. Okay, so that's done. So now come back and then take an AMI, go to EC2 console. Select the public EC2 instance. Actions, image and templates, create image. Create image. Name has to be my public EC2 AMI. And just give some name there. Then just give a description. Give a description. Okay, and then okay, you will see only this one. You will not see this. Okay, because this I created later on. And then say create image. Click on create image. The image would be created. Okay, so wait for the image to be created. Check the progress from images AMIs. Images AMIs. Okay, once the AMI is created, you can go to instances, go to EC2 console, click on EC2 instance and terminate. Okay, once it's terminated, launch EC2 instance. The launch EC2 instance, click on my AMIs. In step 1, to select an AMI, select my AMIs from the left menu and select here my public EC2 AMI and continue as usual. Continue the normal steps. I'm not going to give those steps. You know what those steps are, and launch the EC2 instance. Put it to the EC2 instance. Put it to the new EC2 instance with the new public IP. Okay, should know that. New public IP, and start the web server service. Okay, once that is done, then go to your browser using and access using the new public IP address. You should be able to see the hello world page. Okay, after that, do a cleanup. Cleanup is very important. Okay, what do you do? How do you do cleanup? Go back to your AMIs, select the AMI and edit. Deregister. Just say continue. Yeah, it is deregistered. So you will not see that anywhere. Select the my public EC2 AMI from images EC2 console, images AMI, and actions deregister the AMI, which deregisters the AMI. Okay, and yeah, it should also okay. So what it does is it also takes a it also goes and creates a snapshot, right? You also have to clean that snapshot. So go to snapshots, go to volume snapshots. Yeah, go to EC2 console, EBS snapshots. Select the snapshot which has the create image in it in the description, which has the create image in the description, and select it and delete it. Yeah, selecting it, actions, delete, just delete. Yeah, I just deleted it. Okay, so that's done. So then you have cleaned up your AMIs. So you don't have AMIs, you're not charged for the AMI any longer, and you don't have any associated snapshots, so that you're not charged for it. That's it. And your EC2 instance also, console also looks clean, right? There are no additional EC2 instances running, which is incurring cost for the additional cost for you. Okay, so that's done. So now let's go to Lifecycle Manager. If you see, the Lifecycle Manager that we created has created snapshots. If you see here, if you see, it has created snapshots. Okay. we gave a schedule of what schedule? Every 4 hours starting 4:35 UTC, correct? A maximum of 4 snapshots will be retained. And what is the details? I mean, it'll take a snapshots of all those instances that has that has tags associated with data. Oh, sorry, website. Website is the tag that we gave, right? So now here in this case, my EC2 instance has got a website in it. Website tag in it, correct? My EC2 instance has got a website tag in it. Public EC2 instance has got a tag which says web server. Sorry, web server. Purpose is web server. So now my lifecycle manager took all the EC2 instances which has got purpose as web server, and then it created a snapshot. That's why if you see, it has a snapshot. It has taken both my root volume, which is the 8 GB, and my data volume, which is 30 GB. It has taken a snapshot of it automatically. I didn't take this snapshot. Okay. So now it also has a description that says created for policy, so on so policy. So this is done. So now let's just leave it like that. I'm going to leave it like this for you. I'm going to come back tomorrow and I'm going to show you, how many copies that it has retained as part of the snapshot policy. I'll leave this like this. We'll see this tomorrow. Okay, but you guys don't have to do this because it'll incur additional cost. But I'm going to show you. Okay, it's pretty simple. It's a simple configuration. Right? It's not that you need to do a hands-on with this. That's not a problem. Okay. All right. So I'm going to give this assignment document to you today. So please complete this assignment for today. And again, for ENI and EIP, you don't have to do any assignments for Snapshot Lifecycle Manager. But AMI is important because you will be doing that on a daily basis. When you get into jobs, when you go as a cloud engineer or a cloud support associate, you will actually end up doing AMIs on a daily basis. So it's important you understand how AMIs work and how you are able to deal with AMIs. Okay, so just going to give you the file for November. Yeah, I've just given you the document. Yeah, there's nothing much on PPT for today. Okay, except for this. Okay, if you want, I can give this. Okay, I'll give this anyways. Number 3. Yeah, okay, I've given both the whiteboarding and the document, assignment document. Okay, so please go through this and we can connect back tomorrow. Okay, on a few more topics. And I'll hopefully start, Python by early next week. Okay, I'll give you an introduction to Python. And then I'm also going to, see, next 3 days are going to be important because I'm going to introduce you to IAM. Okay, Identity and Access Management. Okay, and Cloud Formation. Okay, so these are the 2 topics that I'm going to introduce you to over the next 3 days. IAM is a very, very important concept. You guys have to understand IAM very well because IAM is the backbone of giving access to AWS. I'm going to introduce you to that. And then I'm going to introduce you to Cloud Formation as well. Cloud Formation is basically an automation tool within AWS to automate things within AWS. And then early next week, we're going to start with Python. I'm going to spend about a couple of days on Python basics. After that, you will also do some automation using Python on AWS. using Python scripts. Okay. All right. So I think what we can do is we can spend some time either in the breakout rooms. I can join the breakout rooms if any of you have any issues, or if any of you have some serious troubles completing yesterday's assignment, you can correct.
So in that way, I'm just having a doubt that
Okay.
then why do we have to take a snapshot of a volume? Because Amazon is anyways taking care of the volume for us.
Yeah. Okay. Good question. Good question. So now, okay. So now the way it works is there are SLAs for every other service. Okay. Just AWS EBS SLA. So you can just go to search for those SLAs and you will see those SLAs here. Compute service level agreement. Okay, so now you will always see some SLAs associated with every service, right? If you see less than 99.99, this is like 4 nines, and less than 95%. Okay. So anyways, let's not get into that, but to answer your question in a layman terminology, let me just do some whiteboarding. Okay, so you have an EC2 instance. Okay, and you have an EBS volume associated with your EC2 instance. Data volume, it's 100 GB. Okay, 100 GB data volume you have associated with your EC2 instance.
पहली बार है जी पहली बार है जी ting 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 ABC.
Okay, so now what happens is let's assume there is some failure in the underlying hardware. Okay, so now this EC2 instance is created probably, let's assume, on 3rd November 10 a.m. Okay, this EC2 instance got created, and then there's some data that got added to this data volume between 10 a.m. and 11 a.m. Okay, for 1 hour some data got added to this EC2 instance. Okay, so now what happens is when your EC2 instance gets terminated, okay, for whatever reason, right? It could be a human error, or it could be a failure, or whatever it is, right? So now what happens is when your EC2 instance gets terminated, and when you have your when you provision an EC2 instance, you get an option, right? So where you say that, I'll just show you the wizard out here. Yeah, when you add in storage, you see what is this option?
Okay,
delete on termination.
Delete on termination. Yes.
Okay, so now for some reason your EC2 instance gets terminated. Okay, you created the instance at 10 a.m. By 11 a.m. Your data volume, you've started copying files to your data volume. Okay, initially it was like you provisioned it for, initially you provisioned 100 GB, but out of that 100 GB, nothing, no data was there. But by 11 a.m., so 50 GB got copied to that. Okay, by 11 a.m., 50 GB got copied to that EC2, to the DBS volume. Okay, so now, but by say around 12 p.m. something happens to the EC2 instance. Okay, and then your EC2 instance goes down. Your EC2 instance fails. So when your EC2 instance fails, your underlying EBS volume also gets deleted. Okay, so now in such cases, when it is terminated by a user, or when it is terminated by an automation script, or when it is terminated by somebody, or maybe it got hacked, AWS does not take responsibility for that. Okay, AWS
No, sir,
does not
but
take responsibility for that. I'll tell you. I'll explain the
okay.
concept to you. AWS
Yes,
does
sir.
not take the responsibility for that. Now, what point AWS takes responsibility? I'll tell you. So now you have at 10 a.m. you provisioned an EC2 instance. Okay, and then you have copied some 50 GB to it. Okay, to the DBS volume. Now, underlying. So this is basically a virtual. It's basically a virtual volume which is presented to your EC2 instance, right? But if you take the underlying physical arrays, which is actually storing this, right? This will be the physical array, physical storage array. Okay, so where you have multiple physical storage arrays, which will be underlying, which is actually storing this data physically. Okay, so now what AWS does is, yeah, okay. So there will be multiple physical storage arrays associated with each rack or each data center or each availability zone. Okay. So now what AWS does is, now when you have provisioned this 50 GB, right? This physical 50 GB of data that you have provisioned for EBS volume, or this 100 GB of EBS volume, okay, it also gets replicated across multiple physical arrays. It is replicated here. Let's give a name to it. EBS1 is the name of the EBS volume. This EBS1 is present here. This EBS1 is present, sorry. A copy of that is present here also. So that way, when this physical storage array goes down, for some reason, right? It could be a hardware failure at the AWS end. If this goes down, your EBS1, which corresponds to your 100 GB, is still available in another physical storage array. So that way, what AWS will be able to do is, I mean, you will have a small downtime there. Okay, you will have a small downtime where when AWS is actually switching from your physical storage array 1, I'm just going to name it as 1, to physical storage array 2. Okay, when AWS switches this EBS volume from this to this, there will be a small glitch, maybe a few seconds of glitch, where this volume won't be unavailable and your EC2 instance would show a timeout to your applications. But once AWS takes care of moving this EBS1 and pointing your EBS volume from here to here, then everything is taken care. So now AWS takes care of that portion. So where it has redundancy built in the underlying hardware, where any EC2 instance or any EBS volume that comes, it stores a copy of that at a physical array level, so that if there is some issue at a physical hardware level, it basically takes responsibility of that and it brings it back. But when you delete this volume, what AWS does is, it basically deletes this EBS volume from both physical array 1 and physical array 2. So it does not keep any copy of your data, because legally AWS is not supposed to carry or store your data without your permission or without your knowledge. So then it is a breach of trust. So now when you delete this data volume, EBS volume 100 GB through the console or through any other means, or you terminate it, then it is your responsibility. AWS does not take responsibility of that. Is that clear?
Yes, sir.
That was your question, right? So your question was, when you deleted, you still have another copy of it available. So you can still come, you don't need a snapshot.
Okay, sir. Sir, so let's say first I've made an instance with all the configurations, and yeah, I've started it. And then I get one new EBS of let's say 30 GB, and I'll make it attached to that instance. Now you have told that this EBS volume is independent to the with respect to the instance.
Correct.
And I've using the instance, I've stored some data into this EBS volume.
Correct.
Now the instance goes down, but the volume, but the data inside the EBS volume is supposed to be persistent, right?
Yes, correct.
In that case, is it? Yes, sir. In that case, is it required to take the snapshot of that EBS volume? That was my question, sir.
So it is still needed to take the snapshot of the EBS volume, because the data that is present within your EBS volume, right, is your responsibility. What if some user goes and deletes a folder from that EBS volume? You're
Okay,
right.
yes, sir.
Okay, in that case, you still need to take frequent snapshots of your EBS volume, so that if some user goes and deletes a folder, right, and you want to retrieve that folder, then you go 1 hour back or 2-3 hours back EBS volume, get that data folder and bring it back and restore it.
Okay,
volatile memory.
You get the point.
Yes, sir.
That's where snapshots are going to be helpful. Snapshots are not for AWS. Okay, snapshots are not required for AWS to manage their side of things. AWS has got enough mechanisms to manage their side of things, where if you provision an EBS volume, and if there is a problem with the underlying hardware of the EBS volume, AWS has got copies of that so that it can bring it back within the service level agreement. But this is purely for your for the consumer who is actually using the EBS volume. If some file or folder goes missing, somebody deletes that file or folder, then you need a backup of that. It's like typical, where in your home you have a hard drive, and you might want to store all your personal data into a external hard drive just for additional backup, right? If something happens to your hard drive, you can still retrieve it back from your personal hard drive, personal external USB or whatever it is.
Yes, sir. Yes, sir. Yes, sir. That clears my doubts.
Okay, sure. Thank you.
Thank you, sir.
By the way, that was a great question. Okay, so this is how you should actually go dive deep into the subject and try to understand what actually happens. Open the hood and see what happens under the hood. Any more questions?
Sir, yeah, so one more question. Let's say we have started one, that Apache server as such, and it went down for some reasons. Then is there any provision that it restarts by itself and get attached to the EBS volume what we wanted to get data from? I mean,
yeah, you can do that. But you need to build some automation scripts around that.
Okay,
to make this happen. So you can, in fact, in the next 3 weeks or so, I'm going to cover a monitoring topic called CloudWatch. CloudWatch is a monitoring service that AWS provides. Right? Using CloudWatch, you can monitor the health of an instance. You can also monitor custom services, and you can build some triggers. It can trigger an alarm, and that alarm can trigger something which can go ahead and automate this process. That's possible.
Yes, sir. Sir, all these things what we are talking right now are very closely related to this Kubernetes and Docker terms, or the things which are going on in the internet buzz right now. Is it the underlying thing which is on which the AWS is depending on? It is very different with respect to what we are talking.
See, these are two different things altogether. So now if you take Kubernetes or Docker, right? I mean, Kubernetes or Docker is mainly around the application side of things, right? So where you create a Docker image, right? So Docker image is an atomic, immutable container, which stores all the configurations of your application, its dependencies, its runtime, and so on and so forth. And with Docker, you can quickly bring up your application in about a few milliseconds or few seconds. as opposed to EC2. I'll cover that. I'll explain, what is the difference between when you're running an application on an EC2 versus when you're running an application on a containerized way, like your Docker or Kubernetes. Again, Kubernetes is a framework which Google has developed to orchestrate the whole containerized way of deploying your applications.
Yes, sir. Because I mean, because Kubernetes also take care of this container coming down and automatically scaling up down. So I was just thinking if in the background
it's a
this is
slightly
what is
higher
happening.
level. So it's when you take Kubernetes and Docker, right? It's slightly at a higher level. But what we are discussing here is slightly at a lower level, at an infrastructure level.
Okay.
Yeah, you're
sir.
right. I mean,
Yes.
Kubernetes does many things, automatically, but it does it at an application level, not at an infrastructure level.
Okay. Yes, sir.
But now what we are learning here is this is at an infra level where, you're able to basically take snapshots and modify the snapshots and restore the snapshots. Okay. Again, if you
Yes,
go
sir.
back to your shared responsibility model, right, of AWS shared responsibility model, so that covers pretty much a lot of these things, right? So where, if you have a data and if you're storing it in an EC2 instance or EBS, the underlying physical hardware and redundancy of the physical hardware is AWS's responsibility, but the data itself becomes your responsibility, because AWS can't really look into the data, right? Because AWS will not have access to the data, because the security of the cloud belongs to AWS. Security in the cloud belongs to you.
Yes, sir. Yes. Yes, sir. Thank you, sir.
Sure. So any other questions? So, okay, one quick thing. Are you all, feeling excited enough, and are you all able to do your lab exercises? And I mean, what is the complexity level that you're all feeling about some of these lab exercises? Are you feeling that these are quite complex, or okay, or very easy? You want me to increase the complexity levels? Maybe, we should just do some sort of a survey sometime, right? And so that way, we can just do any course corrections which is required. Or do you, some of you might already know some of these concepts, or some of you might have already worked with some of these concepts. So for you, it could be quite easy to understand these concepts. But many of you may not even know what a cloud is, right? When you're just learning cloud for the first time. So, so whatever it is, I mean, you can just reach out to your mentors, right? And you can express it to your mentors, right? And I mean, mentors are all quite keen and quite curious to know, how you're feeling about these, right? And you want certain concepts to be again explained. We are all there to help you, right? But at the end of the day, we want you to be successful in your careers. We want you to have a good ignition to your careers, right? So that you can continue it forward from there, right? I mean, see, the most important thing here is, I mean, of course, technical things. You're learning a lot of technical things out here, right? But in my view, what I feel is the key takeaway is you are basically learning how to learn, right? So that's the most important thing, right? You are learning how to learn a subject, right? Because technology will keep changing and technology will keep transforming itself, right, over a period of time. But at the end of the day, learning is a lifelong pursuit, right? You should never stop learning. You should always keep learning something or the other. Okay. Which will help you, which will help in a larger way, correct? But the learning should never stop, but you should also know how to learn things, right? I mean, that's what I feel is the most important takeaway, right? You're learning how to learn things and what all resources to look at, and how do you go in a structured fashion. How do you learn the fundamentals first before you go deep into the subject itself, right? How do you learn the fundamentals, right? And it's like peeling the layers of onion, right? You keep peeling, it keeps coming up, right? So that way, there's no end to it, right? So you keep learning, and you can go to the lowermost level possible to understand the concepts, right? But again, you have to draw a line somewhere saying that, okay, I've learned enough, which is going to help me. I mean, I'm good with this, right? But having said that, never stop learning. And the most important takeaway for all of you should be how to learn, right? And learn how to learn, and apply that on your day to day, and you have enough time at hand, right? So you can practice as much as possible, right? You can practice as much as possible, and you can keep learning. And there's so much of content available. There's so much of videos available on YouTube on every subject that I'm covering. There's so much of videos available. I'm probably covering some of the most basic things on AWS because there are mix of people, mix of students who are there from different backgrounds, right? So that's where you should basically try and understand and apply all of this on a day-to-day basis. Okay, all right. Any more questions? Or I think you're good to go into the breakout room.
Yeah, I will open the breakout rooms now. If you have any questions, I'll bring it to your attention maybe tomorrow or not.
Sure. Yeah. If anybody wants me in the breakout room, I'm happy to join. I still have some more time, maybe another half an hour I can spend before I get into my day job. I mean, if any of you want me in in any of the rooms, please let me know now itself. I can come there. I can plan to come there. But otherwise, if you're all good, if you all feel that you're comfortable with yesterday's assignment and you don't need any help, I'm good as well. You can continue your today's assignment and let me know tomorrow if you need any help.
Okay, guys, does anyone have questions about yesterday's assignment?